So, number one, we're not doing probability just yet. The following table lists the ages and numbers of players per age group that are on a hockey team. So let A be the set of hockey players who are younger than 9 years old. How many players are in the complement of A? So they don't even care about probability. They just want to know how many people live in the complement of A. So if you remember from set theory, we can use this notation n of A. And this kind of tells us to count the elements in A. And that's basically what we're doing. We're just counting the number of elements that live in this set. So how many elements live in A? So they're saying younger than 9 years old. They're not saying 9 years old and younger. They're saying strictly younger than. So we're not including the kids that are 9 years old. We're only including the kids, whoever these people are. We're only including the people that are younger than 9, which will be the people that are of age 8. How many are there? 7. So this isn't what the question was asking for, but I wanted to go ahead and do this to kind of reintroduce this notation. What they want to know is the number of elements in the complement of A. So if A is the number of the hockey players that are younger than 9 years old, a complement will be hockey players who are 9 years old or older. Or, I was trying to write or, but I don't know what happened. Or older. All right. So how many kids fit this? So 9 or older. So we need to count up the numbers for 9, 10, and 11. And we get, well, these are the ages, and then here are the number of players at that age. So we add those up. 5 plus 4 plus 3. You should get 12. So there are 12 players in the complement of A. Now let's actually do some probability with this. A bag contains each letter of the alphabet. Find the probability that a randomly selected letter from the bag will not be a vowel. So I'm going to call the event that we are looking at, I'm going to call it E, right? And we're concerned with the probability of choosing a letter that is not a vowel. AKA, what does that mean? We want to choose a consonant. All right. So the event we're concerned with is choosing a consonant out of that bag of letters. So we could definitely figure out this probability by counting out the number of consonants in our alphabet and then divide that by the total number of letters in our alphabet. But we can make our lives just a little bit easier by using this idea of complements. So, what's the complement event? Well, our regular event is choosing a letter that's not a vowel. In other words, choosing a letter that is a consonant. Well, the complement of choosing a consonant is choosing a vowel, right? And I think it's a lot easier to figure out the probability of this, E to the C, the complement of E. We can figure this out quicker than figuring out the probability of choosing a consonant. Why? Because there's a lot less of vowels in the alphabet than consonants. So let's figure this out. What is the probability of choosing a vowel? How many vowels are in our alphabet? 5. How many letters are in our alphabet? 26. So the probability of choosing a vowel is 5 over 26. But that's not what we wanted, right? We wanted to know the probability of choosing a consonant. Fortunately though, I can use the probability of choosing a vowel to figure that out. So remember those formulas with the complement? We can figure out the probability of E by finding 1 minus the probability of the complement of E. So 1 minus the probability of the complement of E is 5 over 26. And then this is something you can plug into your calculator. If you do the subtraction here, you get 21 over 26, which is 0.80769. So once again, what we did is, it was easier to find the probability of choosing a vowel because there's only 5 vowels, A, E, I, O, U. To figure out the probability of choosing a consonant, you would have had to go and count all the consonants in our alphabet, which granted, there's not that many, there's 21. So it wouldn't have taken super long to figure that out. But the whole idea here is to show you how complements can work and how they can be really helpful. And in this case, it was just easier to figure out the probability of grabbing a vowel and then using that to determine the probability of getting a consonant. Let's do this one more time. A little different though. So find the probability of randomly choosing a letter other than O from a bag that contains the 18 letters of the Italian city. Oh geez, I cannot pronounce that. Guidonia Monticello? I don't know. I am not Italian in any way, so I butchered that. But anyway, let's write out what we're looking for. What event are we concerned with? They want to know the probability of randomly choosing a letter other than O. So, not choosing O. That's what they want to... So what's the probability of picking out any of these letters that are not an O? Well, once again, you could figure that out by counting out all the letters that are not an O, and then divide that by the total number of letters, which is going to be 18. They tell us in the problem. But it might be easier to figure out the complement once again. What is the complement of not choosing an O? Choosing an O, right? This one's a little bit easier to figure out because we just have to count the number of O's in this word. And how many do we have? Here's an O, here's an O, and here's an O. There's only 3, right? That's a little bit easier to count out. 3 out of 18. So the probability that you would choose an O is 3 out of 18. But that's not what the problem wanted. They wanted to know the probability of choosing any other letter. Any letter that's not an O. And we can use this complement formula once again to do that. So the probability of E is equal to 1 minus the probability of the complement of that E. So we get 1 minus the probability of the complement was 3 over 18. And you can plug this right into a calculator like that, or you can simplify the fractions first. We get 15 over 18. Simplifying that to a decimal, we get 0.8333, and then to go to 5 decimal places, we have another 3. Okay, so that is doing probability with complements. Again, like the problems I did before, we talked about complements. These are similar to the homework problems. So if you're running into issues, pop open these notes, rewatch the video, see if you can figure it out that way. But if you're still struggling, please, please, please let me know so I can try and help you out. All right, y'all have a great week.